Okay. Our next presenter is Gustavo Orozco. He is a certified GIS professional, a surveyor, engineer, and an emergency responder with the U.S. Environmental Protection Agency. He has an advanced certificate in geographic information systems and 2 master's degrees, one in natural resources and environmental management, and the other one in environmental and urban geosciences. Currently, he is working on a postgraduate degree in data science and generative artificial intelligence. Also, in 2021, one of his GIS and environmental analysis research was published by Esri on the Esri Map Book. Volume 36 in 2020, he was one of the winners of the MAPS Excellence Awards in GIS. In 2019, he was one of the winners of the prestigious Special Achievement in GIS Award given by Esri, and with the US EPA in 2016, he was nominated for the Mason Hewitt Award for Excellence in GIS. He works for Tetra Tech as a GIS analyst, Python developer, and project manager. He has been working locally and internationally in GIS analysis, automation, mobile data collection, and data management, supporting the emergency response, climate change, oil, hydrology, and environmental fields for more than 25 years. Please welcome Gustavo.
Thank you, Ken. Thank you. Good afternoon, everyone. Thank you for staying so late, but hopefully it's worth it. So let's start by saying that as project managers, one of our main questions is, how much does it cost? What is the investment? So sometimes when you start a project, you say, okay, we need to do this. But if you put into account automation, some project managers say, wow, that's too cost, the cost is too high or something like that. Well, but that's at the beginning. But if you see on the long run, you are going to save a lot of money. And I'm going to show you with 5 particular projects that I have worked with project managers that you can save a lot of money with automation. So let's start. So my agenda there are case studies. So the first one is with the waste management, the company waste management. I did that in this year. Another one is with the Environmental Protection Agency Region 8 oil program. The next one, EPA headquarters for the Abandoned Mine Lands project. Another one for the Region 9 RISE contract that is with the Navajo Nation. And the other one is with Washington County Lead District in Region 7. After that, we are going to have pros and cons and questions. So let's start by waste management. With this company, they have as-builts for landfills around the United States. And the as-built are in CAD files, CAD systems. So the idea was to do the quality control of the CAD systems, and after that, transfer that to shape files, and after that, to file your database. Each process, or the process for each of the landfills, took approximately 2 hours, and with the automation, went from 2 hours to 2 minutes. And I'm going to show you with a test, with an example. So here is the challenge: generate an automatic process to QC CAD files and to transfer the information to a GIS enterprise database. The manual process, as I said, was quality control and transference. The manual cost was approximately 1,000 files or CAD files, 1 hour, by $110 per analyst is $110,000. With the automatic process, the same steps, quality control first, and after that transference. The investment was 2 minutes, and it was around $3,700. Plus 1 Python developer, 100 hours was 11,000. So the total investment was $14,700. So the reduction of the costs, 87%. That without counting the time, no? So we are going to do a demo, but first, this is the idea. So I encapsulated all the information with Python in a geoprocessing tool. And it was just a couple parameters that you needed to fill out and run it, and that's it. On the right, you can see a complete log of what happened behind the screen. So it's processing all the information with a tolerance, and it's telling you everything that is happening, starting QC process, all that kind of stuff. So, and if there are errors, it's going to generate automatically a CSV file telling you exactly where are the errors and how to fix the errors. Full demo. So let me escape here. Let me go here. Oh, my password. Wait a minute. Okay. So here is the tool. So as you can see, this is the interface, the geoprocessing tool. Behind this, there is a Python script, of course. So the only thing that you need to do is select your CAD file, put a tolerance, a polygon and polyline tolerance, let's say for 99. The landfill, you can put a buffer. So at the beginning, everything was tolerance 0, but the manager said, no, that's not possible. Nothing is perfect. So probably you can put something that you can change the tolerance very easily. So I put these two lines. A quality control, a monitoring period is Q4. Let's put today. And the another thing that they wanted was to transform or reproject to 2011, not 83 projection. So internally, the Python script is going to manage all the transformations. And there are 3 types of run: the QC run, another to the QA SD transfer, and another to the production SD database. But of course, in this case, we are going to do the QC run. Let's say how long it takes. If I can move this, and I can just run it. I think so. I didn't run it. Okay, run. Okay. So it's running the Python script. So it's telling you what's going on. And hopefully I'm not going to bore you, but it's going to take around 2 minutes before was 1 hour. So that's good. So if you put tolerance 0 and 0, it's going to generate the CSV file telling you, hey, I'm not perfect. Give me a little tolerance. So, okay, starting the QC run. Okay, it passed the QC run, finishing the QC process. Now it's starting to add fields to different feature classes and all that, opening the information in different feature layers that are going to the production database at the end. So before they were doing the QC manually, of course, and after that transferring to shapefiles, and after that to geodatabase. I said, no, CAD file to geodatabase is straight is good. We can halt that process. It's generating some buffers. Seems longer when you are waiting. No? Oh my God, please run. I just tested this morning and it took 1 minute, 59 seconds. So, okay. At the end, it's going to tell you how much time to run all the process. Almost there. Okay. 1 minute, 55 seconds. Yes, better. Okay. Okay. So that was it, the demo. Let's close this. Let's go back to the presentation and let's continue. Okay. Next, EPA Region 8 oil program. So for this one, the EPA has FRPs that are facilities with more than 1 million gallons oil, and they need to be regulated, and they need to have spill projections. So when you have 300 facilities with the spill projection, you need to create the projections in order to be able to respond more efficiently in case of a spill in any of the facilities. You need to know how long or how far that spill could go and how to respond. So they need to create spill projections, and it was doing manually because sometimes you use trace downstream and sometimes it's not very good. So I automate the process, and these are the results. So the challenge: generate FRP spill projections. The manual process: creation of spill projection, verification, and incorporation into a geodatabase. Manual cost for 15 FRPs, 15 minutes each, is $5,912. The automation is the creation of the spill projection, verification, and incorporation, so you can automate all the process. And the investment was one Python developer, 15 hours, and it's $1,650, and the reduction was 72%. In this one, I use a model builder as well with the Python script. And of course, for security purposes, we cannot see the exact location, but that's region 8. And you can see the blue lines are the field projections, that's the final result. So that's it. Next case, EPA headquarters, abandoned mine lands. So the EPA has a lot of tasks for these abandoned mine lands, of course. And those tasks are throughout the year, there are a lot of tasks. And the general managers, they wanted to know statistics about these tasks. And in order to run those calculations, if you do it manually, there are very complicated, complex calculations. So I put everything together in a Python script, in a notebook, and we are going to see the results now. The challenge was to generate an automatic process to update calculations in a dashboard each time updates to AML are present. The manual process, data calculations, and transference to dashboard. The cost, 2 hours per update. So for $110 is $220 per update. The automatic process, data calculations and transfers to dashboard, same process. 2 minutes per update, so it's $10. The reduction, 91% in the costs. And this is an example of the dashboard. As you can see, there are filters. This is just filtered by support and filtered by status. These are here. Type of support, fluid hazard consultation, optimization, and technical support. And the status is completed or in progress. But behind that, there are very complex calculations. And well, with the notebook, it was a 91% reduction cost. This is an example of the notebook. So that's kind of the idea. The next one is the Region 9 RISE project. This was very challenging because at that time in the industry, and this is about metadata. So let me run out that a little about what is metadata and all that. So of course, in simple terms, is the data of the data. So to understand who, what, when, where, how, and why of the data resource is important for data distribution, data management, and project management. So what was the challenge? We received from different organizations more than 2,000 feature layers, rasters, tables, and the EPA wanted to be that those items be in compliance with EPA metadata. So when you are talking about that, is you need to check 2,000 files, all the metadata is a lot of time. At that time, it was not a tool that allowed you to check for compliance in a batch. So I generate a program that does that, and it's going very detailed to tell you what is in compliance and what not, and where is the issue. So that was the challenge. They have certain standards, so you need to follow those standards, and it was mandatory. So we said, okay, that's going to take us like 6 months to run all those to see if everything is in compliance. So what happens is that was the challenge. The manual process was verification of compliance by item, was around 2,000 items per 10 minutes. If you are good, 10 minutes per item is and $110 per analyst is $37,000. The automatic process is going to do the same, but now you have 1 minute for 50 items, not just one, but 50 items. So at the end, the cost was $8,910, reduction 76%. And if you see 1 minute is going to be around like probably 20 days instead of 6 months. So my project manager, the general manager said, "Oh, what? You have that reduction of cost?" I said, "Yeah, just with automation." So yes, that was the reduction. And this is the idea. So I encapsulate that in several steps. The first one was to edit and run model feature classes. The another one, tables and rasters, because we have those elements. After that, run an XML formatting method. So have you heard about pre-print? So you needed to reformat that before run the compliance checker. After that, you run the compliance checker, which is the end. Here you have the geoprocessing tool, and it's going. This is the back end, the models that I use for the Python script. And at the end, you get a simple CSV file or Excel file telling you, hey, this is the feature class name or raster. Is it compliance? Yes. True. Otherwise, where is the problem? And it's telling you exactly where in the metadata is the problem. So you can go directly there and fix your problem until it's in compliance and run the checker again. That was the challenge. And the last one is, again, for the EPA Region 7, Washington County District site. So the idea is that they go to the site, and it's residential, and they take samples by cells. They send that to the lab, and the lab is telling you, hey, yeah, the lead values that are there are too high. So you need to remediate. So they need to excavate, take that to the lab, remediate, and take that to the lab again, and resample, and say, okay, the post-excavation around have these results per cell again. And well, you are good to go, or you need to do more remediation. So that's kind of the general process. So as GIS analysts, our task was to create field sheets for the excavation crew. So before they go to the field, they have the sheet and they know, oh, this is the cell number 1, we need to excavate here. That cell is green, so the lead is low, so we don't need to excavate that. And after that, count the cubic yards and charge that to the EPA. No? So that was the process. So it was, they needed to call us because everything was in a GIS server behind the firewall. So just GIS analysts could go there and create the field sheets. The guys that were in the field, they couldn't do it. So that idea was to create a Python script that allows them, through a web mapping application of Experience Builder, allow them to just create that automatically. In 30 seconds, they create the field sheets. So here is the challenge: generate field sheets on the fly. The manual process was a GIS analyst created the field sheet from GIS server. approximately 30 minutes. Is $55 per each of the field sheets of the sites. The automatic process, any user create a field sheet outside of GIS server. Automatic investment, 1 minute of the creation plus the developer portion, 24 hours, is $2,640, and the reduction was $58. But now they can do it. They don't need to call us, hey, can you create a field sheet for this residential property? No, they do it on the fly. And this is kind of the idea of the field sheet. So it's creating all these that they take to the field, to the excavation crew, and give them that, and okay, this is where you need to go and excavate. And it's creating with this information, square feet and depth is calculated automatically the cubic yards, so they know how much to charge to the EPA at the end. So that's kind of the idea. And if I'm going too fast, let me know. Okay. Okay, so the final part, pros and cons. So of course, the pros, efficiency, short, mid-cost to mid-cost benefits, of course, repetitive and reusable, and AI leverage. The cons, initial investment, of course, a lot of project managers say, well, it's too much. Yeah, but if you go to the long term, how much are you going to save? And I show you in 5 real cases how much I save these slides. Constant technology updates is another con. Of course, sometimes, I don't know, in Python they change something, or HTML or Java, so there is not working, so you need to update the code as well. But it's minimum, so that's kind of the idea. Questions? Questions? Any question? Yep.
Stay within the time frame that you propose to do the automation?
Yeah, mostly. Yeah. So always I'm going to a project, I ask the time frames, and if it's not possible, I let them know, okay, that's not possible. You cannot generate a Python code or Java or whatever in 2 hours. Some project manager says, I need this for tomorrow. Okay, good luck, guys. I don't have the time, and I'm not going to do it in 2 hours. Yes.
The last piece looked like a map layout type deal. What software did you use to do that?
RGS Pro. RGS Pro. So it's a combination between RGS Pro, RGS Server, and RGS Online. So I generate everything, all my routine in RGS Pro, all the Python code in RGS Pro. I publish that, the result. When I run that successfully, I publish that to an RGS server, and in RGS Online, I connect that service in RGS Online. So that's how it's done, and it's on the fly. So anyone with the web mapping application can go and just type, hey, I need this in an aerial for 2024. I need a pre-excavation field sheet or post-excavation field sheet. And this is the property that I need, and this is the name of the PDF. Run, and it's going to generate that in 30 seconds. Yeah, that's the process.
Did your company set up the web map or the web application for the end user to use?
Yeah.
Okay.
Everything. And we can set up that in the organization's RGS Online.
Okay.
So for example, now I have 3 projects in Hawaii, and I'm working with the county of Hawaii, the RGS Online organization.
Yeah.
So directly. So when I finish, they can transfer that easily to anyone else that is manager, GS manager of the Hawaii county. So that's really, yeah.
Cool. Thank you.
Yeah. I think so. That's it. Here is my contact information.
One question.
Oh, sorry. Yeah.
I think 1/3 of them are used there.
I have time. Hopefully, but I don't. Yeah, we can talk. Yeah. So So here is my contact information, and thank you so much for your attention.
Sorry, I unplugged you.
No, it's okay. It's all good.
Good job.
Thank you so much.
This is specifically for EPA client?
No.
No.
No,
It's everybody.
any
Any
type of
client.
guide. We do automations, all that kind of stuff. And yeah,
So I work at SBS Engineers. We're working with waste management. on
Okay.
This conversion thing
okay,
too.
cool.
And I was wondering, 'cause, that's awesome, John, that you made a thing.
Thank
I know one of the challenges with the as-built is taking the data from the local, like these local coordinate systems that
Yeah.
are in, and then putting them into, like an actual coordinate system. When you're running this code, taking it from CAD to GIS, is it already like in the proper geospatial coordinates, or does your code handle that as well?
As part of the quality control in waste management, they need to have it, the proper.
Okay, so you're doing this once everything's in the proper coordinate system.
Well, even though they are in the the proper coordinate system, they need to be transformed to 2011. From NAT 83 to 2011 NAT 83. And there is a transformation, even though the datum is the same, there is a transformation because 2011, because 2011 is higher accuracy, so you need to transform, even though the datum is the same, NAT 83. So the code is handling all that
Okay.
internally.
Okay, so the code,
Yeah.
if it's not, it will put it in.
It's telling you, yeah.
If it's not in
2011 is doing. Yeah, exactly.
It's still like you're not taking information that was in these local coordinate systems or anything.
No, because it's part of the quality control.
Okay, yeah. So you're-
The code needs to have, and the code detects that.
Okay.
If it's not in NAT 83, it's telling you, hey,
Okay.
I cannot process the information because it's in the wrong coordinate system.
Um,
So they need to correct that and send it back because that's part of the quality control. So, yeah.
Kind of like one of the biggest changes for this as a whole is like, getting stuff from these local.
Oh, yeah.
Customing it into.
Local and custom.
Custom,
Yeah, it's a pain. So that's why waste management said, no, you're going to send me the bill, need to be in the right coordinate system